Welcome back to the tutorials of Graph. In the previous videos, we have seen how we can create and modify a brain atlas and an fMRI cohort using Graph. Here, we are going to get familiar with the fMRI graph analysis package of the toolbox. In order to start your analysis, you have to load an fMRI cohort saved in .fc format. If you have opened the fMRI graph analysis directly from the fMRI cohort interface, the fMRI cohort is already uploaded. To upload the cohort, click on the Select Cohort button. Now you have to find and select the cohort you have created. I'm going to use the cohort that we created in the previous video. After you select your cohort, all the buttons which were disabled become enabled. After you load the cohort, its name, the repetition time, and number of subjects and groups appear. If you want to see the cohort you have selected for the graph analysis, you can click the View Cohort button and the fMRI cohort appears. Note that you cannot modify the cohort here. If you wish to do so, you need to go back to the fMRI cohort package of Graph. In the box below the cohort panel, you can assign the desired name to your graph analysis. Here, I change the name of my analysis into My Analysis. To perform your analysis, you have to define a connectivity matrix for each group. You can choose the type of your graph from this drop-down list. The connections can be weighted undirected or binary undirected with fixed threshold or fixed density. In this drop-down list, you can choose the correlation which you want to use for the connectivity matrix calculation. And finally, you can decide what to do with the negative correlation coefficients. In the main panel of the interface, you can see the visual representation of connectivity matrix. If you want to export this figure, click on the Figure menu and click on Generate Figure. If you want to see how the data values are mapped on this matrix, you can click on Color Bar from this toolbar. For getting the correlation coefficients between pairs of nodes, activate the data cursor and click on the upper left corner of the desired square. The z-value is the value assigned to this square. On the right side of this panel, you can choose the group whose connectivity matrix you want to see. You can deselect this checkbox if you want to visualize the connectivity matrix of an individual subject. After you have selected it, this drop-down list gets activated, which includes the subjects of the selected group. You can select the subject whose connectivity matrix you want to see. By clicking on these checkboxes, you can visualize the weighted correlation matrix. You can see the distribution of the correlation coefficients. Or you can visualize the binary connectivity matrix for a certain density or threshold. For indicating the threshold or density, you can either use these sliders or you can enter the desired value. To define the communities, I move to the Community Structure panel. At the beginning, no communities are defined. If you want to use the default community structure, click on the Default button. By doing so, the structure is defined as a dynamic community structure, which allows the toolbox to recalculate the structure for each connectivity matrix separately throughout the analysis whenever needed. The algorithm used for this purpose is the Levene algorithm, and the value of gamma, the resolution parameter, is 1. If you wish to change the community structure, you should click on the Edit button. After clicking on it, this interface appears. First of all, if you want to hide or show labels, spheres, symbols, grid, axis or brain surface, or have different views, you can use this toolbar. If you right-click on the brain figure, you can see other actions provided for better visualization. If you select Brain Settings, an interface appears in which you can modify the brain color and the color and transparency of its faces and apes. If you select Brain Region Symbol Settings, another interface appears. In the list on the left, you can select the regions whose symbols you want to change. By checking each of these boxes, you can see the labels, names, coordinates, or hemispheres of the selected regions. By clicking on Show Regions and Hide Regions, you can show or hide the selected regions. By choosing the symbol from this drop-down list, you can change the shape of the symbols. You can also define the size of symbols. For changing the color of the symbols and their aids, use these buttons. By selecting Brain Regions Sphere Settings, you can alter the spheres representing the brain regions. In this interface, you can hide or show the spheres by clicking on the Show Regions and Hide Regions buttons. You can change the size of the spheres, the color of the spheres, their faces and edges, and also their transparency. In the case that you select Brain Regions Label Settings, you can change the font size and style of labels, their color, and interpreter. To generate a figure, you can use the Figure menu. To define your community structure, you should use the panel on the left side. In the table, you can see the brain regions and the modules to which they belong. You can define the structure manually. By clicking on the initial module to which a region belongs, you can add it to a new module. By checking the checkboxes corresponding to each region, you can assign them to one of the existing modules. Notice that regions with the same module have the same color. Below this table, you can define the parameters for the calculation of community structures. First, you have two options, either using a fixed structure or a dynamic structure. To select one, you should click on these boxes. If you click on the Dynamic Structure button, these tools get activated. By selecting one of these checkboxes, you can select the algorithm you want to use for the calculation of the communities. You can define the gamma value in this box. Here, you can assign the density or threshold of connectivity used for the calculation of the communities for the cases of beauty and beauty graphs. You can choose for which group or subject you want the community structure to be calculated. If you want to calculate a community structure for a subject, you should click on the Subject checkbox, otherwise click on the Group checkbox. After you have assigned all of these parameters, you can calculate and visualize the communities by clicking on the Calculate button. If you want to reset the community structure to the latest saved one, click on the Reset button. At last, if you want to use this community structure for your analysis, you should click on the Set button. Here, I want to recalculate the community for the first group and assign it as a fixed structure to my analysis. When you have finished dealing with the community structure, close this interface and go back to the fMRI graph analysis interface. By clicking on this checkbox, you can rearrange the regions in the connectivity matrix in accordance with the modules of the community structure. By clicking on the Divide Communities button, boundaries for each module are shown. After you have defined the community structure, you can start your subgraph analysis. To do so, you should click on the Subgraph Analysis button. When you click on this button, another interface appears, which is very similar to the community structure interface. Here, you can either define the subgraph that you want to use for your analysis manually by clicking on these boxes on the left panel, or you can use the community structure modules by selecting your desired module from this drop-down list. After you have decided your subgraph, click on Set to assign that subgraph for your analysis and click on Start Analysis. You can see that a new fMRI graph analysis interface appears in which you can modify the parameters for the subgraph analysis. I get back to our original analysis interface. In the first column of the table at the bottom of this interface, a list of measures is shown. In the second column, you can see whether a measure is a nodal measure or a global measure. And in the last column, a brief description of each measure is provided. Remember that this list changes based on the type of the graph that you have selected for your analysis. When you finish the preparation of your graph analysis, you should save it. Notice that Brave saves it as a .fga file, which can be used by the fMRI graph analysis package of the toolbox. If you want to start your analysis right away, click on the Start Analysis button. I will explain this part in the next video. Thanks for watching.